Okay, we're going to begin with the first lesson in Unit 8 on solving exponential equations using the same base. So you can see here that we are going to look at the property of equality and identify that if we have the same base, then we can actually take the exponent and equal it to each other. So if we look at example A, we can see in this example that the same base was 5 and the exponent is 3x plus 1 and 4. So we can take those and equal it to each other. So we can see over here our first step is to use the property. And let me make it a little bigger. There we go. Use the property of equality to equal the exponents. Okay, and that will be your first step. And then from there we can see that all you have to do is solve for x to get x equals 1. And let's try an example. So if we have this equation, we can see that we have the same base, and it is 3. So now I can take the exponent on the left side and equal it to the exponent on the right side. And then from there I'll continue to solve. So I'm going to add the x, so I'll get negative x, subtract 3, I get negative 3, divide by negative 1 to get x equals 3. In order to confirm that, we can always check our work, and we will substitute it into the original equation. So we have 3 to the negative 2 times 3 plus 3 power equals 3 to the negative 3 power. And on this side, you can see I will get 3 to the negative 3 power equals 3 to the negative 3 power. So it does work. We don't need to really do anything further because we can see that that would be true. Let's scroll down and look at example B. And we can see here that on the right-hand side, we do have same bases, but on the right-hand side, we have some multiplication first. And you can see it says, step 1, simplify using the properties of exponents. So we want to combine the 7s on this side, so it's just 1 7 over here and 1 7 over here as the same base. And what we do with the exponents on this side, since they're being multiplied, we can add the exponents. And then we can use the property of equality again to equal the exponents, which we can see right here. And step 3, solve for x. All right, so very similar, just one step before doing the same base. Now, let's try one on our own. Okay, this time we're doing division, so let's deal with this side of the equation first. And I'm going to use the quotient property and subtract, so I will have 6. Negative 3x minus negative 6 is going to be negative 2x equals 6 to the negative 3x minus 2. We'll leave that. Now we have the same base on each side, and we can equal it to each other. So now we'll have negative 2x. I'm going to move this up so I have more space. Okay. And I'll equal negative 2x equals negative 3x minus 2. I'm going to add the 3x over here, so I'll have x equals negative 2. And again, we always want to check. So 6 to the negative 3 times negative 2 power divided by 6 to the negative 2 power equals 6 to the negative 3 times negative 2 minus 2. And I will end up with 6 to the 6th power divided by 6 to the negative 2 power equals 6 to the 4th. Oops, this is not negative 2 power. This is negative 2. So that'll make that positive. And you can see we'll subtract and we'll get 6 to the 4th does equal 6 to the 4th. Okay, let's go to the next page and look at example C. All right, let's look at example C. We can see that we have 1/3 to the negative 2x equals 81. We do not have the same base right now. But you can see here what they did was take 3 to the negative 1 to the negative 2x power. and this side we can write 3 to the 4th. So we could find a way for them to have the same base. So we're going to say that the first step for this one would be rewrite each side of the equation to have the same base. And then from there we can follow the same steps as we did for letters B and C. All right, let's try together, and we will rewrite 2 to the 4th, because that would be 16, to the negative 2x power equals 2 to the 6th power. We know that this would give us 2 to the negative 8x equals 2 to the 6th. So now I know I have negative 8x equals 6, and so that will give me x equals negative 3/4, because I'll divide by negative 8. And again, we want to substitute in just to be sure that we did it properly. So 16 to the negative 2 times negative 3/4 power equals 64. This will give us 16 and 3/2 equals 64. When we know that 16 3/2, we can type that in our calculator, or we could also rewrite it as a radical. We know that 16 cubed, the square root, equals 64. And it would be the case that 4 would come out. I'm sorry, 4 times 4 times, you'd have several 4's in there, and you end up with 64 that would come out. Okay, because you have 4 times 4, 4 times 4, 4 times 4. So 64 would come out and equals 64. Scroll down to example D. In this case, we have, it says step 1, change to same base. So we can see that we do not have the same base right now, and we would think that this one would be 3 is going to be our same base. We can rewrite this one to be 3 to the negative 3 power, and this would be 3 to the 5th. And then from there, again, we can follow the same steps as before. Okay, using the properties of exponents and the property of equality for equal exponents. Okay, so let's look at this one and do this together. I'm going to keep this as 3 to the 2x times 3, so we know we're going to add exponents, so I'll have 3 to the 2x plus 1 equals 81, but we can write that as 3 to the 4th. And now I'll equal 2x plus 1 equals 4. Subtract 1. I know 2x equals 3, so x equals 3/2. And I substitute back in to get 3. And we're gonna substitute it in to the original, so 3 to the 2 times 3/2 times 3 equals 81. And I'll get 3 to the 3rd times 3 equals 81. And I know that'll end up being 3 to the 4th, which is 81 equals 81. So we can confirm that it does work. I want to look at one more page. And I want to just kind of go over the summary of the steps, and we can see that the first one would be rewriting to have the same base on both sides of the equation, and then simplify using the properties of exponents, and then from there you will equal the exponents and then solve for x. Those are the 4 main steps you need to understand in order to solve exponential equations with the same base.